You will master SQL joins and join conditions in under 10 minutes. Let's go. Let's say we are shipping our friend's items over the ocean. Bob gave us a ball, and Joe gave us his hat and his car. We will store a unique identifier for each friend, and then the friend's name for our people table. Then we add the person ID and an item name in the items table to store all the items we are sending over with the ID of the person who owns the item. The first step in a join is to use a join condition to determine how to combine the rows. The natural join condition matches rows from the two tables that have the same values in the same named attributes. In this case, we will match items with people if their ID values both reference the same person. In this case, the row for ball has an ID of 1, so we can match it with Bob, who has an ID of 1. We can take our same named attribute as person ID and merge it into one column. We can then take the unique attributes from the first table and then the second table. We get one match on the ID of 1. Let's combine the row. We first add the ID into the merged ID column. Then we can add the person's name from the left table. Then we can add the ball from the right table. Now we can see why we are joining these tables. We can combine item information and its owner information in one row, so it is easy to see which items we have and who owns that item. We have matches for the ID of 2, so let's quickly combine these rows. For this match, we add the ID, then the person's name, and then the item name. Let's quickly add our last match for Joe's hat. Okay, now we have our matches. If we only want our matches, then we can just run an inner join. Let's add a person named Jen that does not have an item. Let's also add a box that there is no owner of in the people table. They won't be in the inner join since they have no match. We can run a left join to also include the rows in the left table that do not have a match. We can then add in Jen with her ID of 3, then her name, and then null value for item because she has no matching item in the item table. Now we have all our matches, but are confident that every person is in our resulting table, even if they don't have an item. Now, let's do the right outer join. Instead of adding Jen, we add the box without an owner, so the name will be null. Here is the right outer join result. Now let's say we want the matches, the unmatched rows on the left table, and the unmatched rows on the right table, then we can run the full outer join. Let's move up the matched rows for extra space. For the full outer join, we also add the unmatched rows on the right and then the unmatched rows on the left. Let's code this up. Let's configure the items database. You can see it's the same database as our example. Let's now work on joining these tables with code. Let's write a select asterisk clause to get all the columns. Then let's write from clause saying get data from the people table. Then just write left natural join items to do a left outer join that uses the natural join condition. We see we get the matches and Jen who doesn't have an item. Let's change the left keyword to a right keyword to get the box instead of Jen. Now let's write the full keyword to get Jen and the box in a full outer join. We can also remove the full keyword and just say people natural join items to get the inner join. Now, let's consider a case where the item name is under an attribute called name instead of item. In this case, we would need the ID and the name to match for us to match two rows. Of course, no one has the same name as the item they own, so the inner join gives us no matches, the left join just gives us the left table, and the right join just gives us the right table. Let's initialize this database as the double items database. Let's code it up the same way as we did before where we have the natural inner join of the two tables. Now we remove the natural keyword and put the using keyword with a comma-separated list of same named attributes that we want to join by. We want to join by ID, so let's write that. Now our joins work like they did before, and it just treats the name attribute as different columns. We can run the left and right outer joins as well. Now, let's do the left anti-join. The left anti-join only gets unmatched rows from the left table. First, we run the left join, which yields all the 3 matches. It also adds our unmatched person. Now the question is, how do we only retain the unmatched rows? Well, we simply only want rows from the left join where the unique attribute from the right table is null. In this case, the only person missing an item is Jen, so she is the only row we get for the left anti-join. Now, let's code up the left anti-join. Let's first run the left outer join. When we execute it, we see that only Jen does not have an item. We add a where clause to only get the rows where the item is null, and now our result only keeps the people who do not have an item. Now, let's code up the right anti-join. We run the right join, and we see that box has no name for the owner. Now, add the where clause to filter out rows that match someone in a person table by only retaining rows with a name of null.
Hey, it's Ben from the boat. Please give me a list of people who have an item being sent, but only give me data for the people, not the items.
Okay, well, we want the attributes to be the same as the people table. Let's use the natural join condition to find matches. Bob has a match, so we add Bob. Joe has 2 matches, so we add him, but only once. Jen does not have a match, so we don't add her. Now we essentially filtered the left table to only retain rows in the left table that match at least one row in the right table on the natural join condition. This is called the semi-join, where a left semi-join includes attributes from the left table, and a right semi-join includes attributes from the right table, but we don't get all the attributes in either case. For the left semi-join, first right select star from people to get data from the people table. Then we write a where clause that only keeps rows where there exists a row from the items table where the item ID is equal to the ID of the current row of the people table. This code is a bit tricky, so let's walk through it together. First, we run this from clause in the outer query to get data from the people table. Next, we run the where clause for each row. Then we run the from clause in the subquery to get data from the items table. Then we filter out rows in the items table that don't have the same ID as the ID in the current row of the people table from the outer query, which means we only retain this row, and we just select a dummy value of 1 for it. Then we run the exists check, and since there is a row in the resulting table from the subquery, we get to keep Bob in the result of our outer query. Then we just follow that protocol for each row in people, so we retain Joe, who has a car and a hat, and remove Jen, who has no item. We can write the inverse of that to get the right semi-join. And we will just get our items that have an owner in the people table. The next join type we have is the self-join. Joining the same table by itself may seem silly, but in some cases it can be useful. Here we have an employee table with a unique identifier, a name, and the ID of their manager. We might want to join the 2 tables together so employees' information and their manager's information can be together on one row together. You can see that we have our employees table. Now let's select all of our rows from the employees table that is left joined on the employees table. We will rename the first table as E for employee and the second table as M for manager. Now in this case, let's write our own custom join condition using the onJoin condition, which takes a predicate that is an expression that evaluates to true or false to determine if the rows should be matched. We just say on E's manager equals M's ID to say match a row if the employee's manager ID is equal to the manager's ID. Keep in mind the on condition does not merge same named columns like the other 2 join conditions. Now we can see Brenson works for Jensen, Jensen works for Bobson, and Bobson works for no one. If we want to just do a join that matches all rows, then we can do the cross join, written out with the keywords cross join, or just by comma separating the tables. We can see this matches every person with every item. Now, for the theta join, a join is considered a theta join if we use a condition in our join like the less than operator or the greater than operator. A special case of the theta join is the Equi join, where we use the equals operator in our join. I'd like to thank my mentor, R3PR0B8, for helping me improve this video.